Hi everyone, welcome to this Aim High Live. I didn't do one yesterday. The timetable started to move around now, so I don't. I'm not going to be doing them necessarily every day. Although today I am doing three lives. Three. So yeah, if you're around today, then I'm going to do one now, and then one in an hour, and then another one. There's loads. But yeah, thanks for coming. If this is your first time, then this is an Aim High Live. So I'm gonna talk about today. I'm gonna talk about what are the tipping points for our climate. But ask questions whenever you want. And yeah, right. Hi, Shane. That's Ben. Yeah, I'm going to talk about the tipping points for our climate. And yeah, ask questions whenever you want, and we'll see where this goes. Yes, so if you're watching on one of my channels, on my Facebook or my YouTube, then you will find everything on here because all the other people who are running these only go out on here. You won't find them on my channels. So do head over there as well. But yeah, just say hi to everyone. Hi, Miz. Hi, Lily. Hi, Catherine. Roz is here. Leonard's here. All right, okay, so let's get going. So yeah, today's going to be about what are the tipping points for our climate. Wait, I'm just going to grab that so it can sit on top the whole time. But first, I want to ask you guys, what do you think? And actually, I can't remember where I learned this. I feel like I might have learned this as part of live. Okay, anyway, so these trees here are called acacia trees. Where do we normally get acacia trees? Like, what does this scene look like? Where is this? Where is this? Whoa. So yeah, acacia trees. Where are they? And what's mysterious about them? Okay, so Miz is saying somewhere in Africa. Yes, okay, so normally people associate this kind of view, and not often you see them from further away, so they look a bit more like this. People associate this kind of appearance with with like a savanna in Africa, But have you ever noticed that exactly. Brody's coming in saying like Lion King as well. Oh, go with that. So yeah, but there's a very big mystery about these, and that is, have you ever noticed that they're all the same age? They're all the same. They're all the same height. You don't see small ones and you don't see much bigger ones. They're all the same. And that's why it's so easy to associate this tree with that African view, because almost every single picture you see with a tree in it in the savannah, the tree is this age. Why are they all the same age? What do people think? Why are all the acacia trees the same age? Let me know what you think in the chat. It's a bit of a mystery, and I only found this out really recently. So yeah, let's label this as well as the. How do you spell savannah? God, I'm so rubbish at spelling. I think it's like that. So yeah, this is the African savannah. Why are all the acacia trees the same age? Right, if you are joining late, then this is an Aim High Live, and today I'm going to be talking about what are the tipping points for our climate. And before we get going, I'm just asking people why they think all the acacia trees, which is this classic African scene, why they all look the same age. They are the same age. And yeah, if you're watching on my Facebook or my YouTube, then do check out aimhigh.co, which is invisible at the moment because it's kind of hidden in here. It'll be visible again one day. It's at Aim High Live as all the social links as well. And yeah, do just also to explain this to anyone whose first time this is. A group of us have got together to run these free things online every day, so that there's something much more fun to do than school, which is maybe a bit rude to school. And actually, some schools might be offering quite good things, but I think a lot of schools are really struggling to do something to do something good with the resources that they have. So what we've done is we've come together to try and do something positive to like give you some interesting stuff to learn about. And that's why after this, so most of them are on like interesting topics like what are the tipping points for our climate. But after this, the one next is me talking about GCSE electricity because I'm just going to teach you how to do that really easily. So yeah, that's 11. So tell anyone you know who's been struggling with like electricity in any of like ages 12 up to 16. I'll help them out. That's in like when is it like an hour? Okay, so let's see what people think. Miss says they're all twins, but many, many twins. Lily's asking if an alien dropped the seeds and they don't reproduce. And Catherine's saying evolution, so the saplings can't grow in the climate today. It's none of these, but these. I like that idea, Catherine. And Miz is saying, what does savannah mean? Is it a type of place? So yeah, savannah is like the African grasslands that you get all of the. That's like the Lion King scene. The Lion King scenes. Okay, so Marion is saying, well, that's blah, blah, blah. Okay, Simon's saying maybe they stop at a certain point, or are they actually the same age? So they are actually the same age. Like all these trees are the same age. I can't remember exactly how old it is, but it's about 150 years, 160 years. Something happened. There was one year where something really big happened all across the plains of Africa, and all of these trees then started to grow that gives us the scenes that we have now. So if you went back a couple hundred years, you would not have this same scene of all of these trees. Something big happened. What do people think it is? Catherine's asking, are they like Pando? Okay, so for those who don't know, the biggest tree in the world is this tree called Pando, which is basically it looks like about 30,000 different trees in a forest, but actually it's all the same tree that's kind of like gone underground and then come up again to disguise itself as multiple trees. And it's a tree called the quaking aspen. You should check it out if you haven't seen it before. But quaking aspens are a weird tree that are all either male or female, but not both. So Pando is a male quaking aspen that's absolutely enormous. That just like kind of swims around all these female quaking aspens in this huge forest that it completely controls by itself. Okay, so guesses. Lily's saying rain, Miz saying big storm, Rudo's saying earthquake, or earquake. Earquake. I don't know who was here before, but does anyone remember why Mars has Marsquakes? Because it's a totally different reason. Sorry, total tangent, but just like laying down a challenge for people to see if they remember. Here's Mars in the background. Why does Mars have Marsquakes? Why does Mars have Marsquakes? I want to see who remembers that. From the other one we were doing before. But anyway, sorry. So there's a lot of people. So there's a dust storm and a tornado. Okay, so a lot of people are guessing like very physical things that happened that might have allowed all the acacia trees to grow and all become the same age. And Marion's saying soil erosion. Emily's saying drought. And Marion's saying degradation. It's not a physical thing, actually. It's actually something really quite unbelievable that happened. It was a magic made it happen. Yes, exactly. I mean, literally unbelievable. No, so what happened was there was a disease, a disease called Rinderpest, and this disease swept across all of the kind of cattle-like animals of the world, so all of the cows and wildebeest and things like that, and just wiped out almost like huge amounts of the population across the entire planet. And for 1 year and 1 year only, all of these acacia saplings were able to grow tall enough such that the next year, when the population started to recover, they were already tall enough to sustain themselves, and they normally wouldn't have been because the grazing animals would have destroyed them. So it's kind of beautiful in a sense in that these acacia trees are all are all like what remains of that actually quite terrible time. Sarah's coming on late and saying hi. So yeah, just to remind people, just to let people know who are joining late what's going on. This is an Aim High Live, so you can ask questions whenever you want. I'm going to talk about what are the tipping points for our climate. I was just doing a little beginning about acacia trees and why they're all the same age, which is this big mystery that people couldn't solve for such a long time. And there must have been so many like people who went through the African plains and spotted all kinds of things, like interesting new species and stuff like that. And then eventually some smart person will have gone along and been like, oh my god, all of these trees are exactly the same age. Anyway, big mystery for a long time. Turns out that there was a disease called Rinderpest that wiped out loads of the grazing animals, and that allowed all of these trees to grow, which is why that's what Africa looks like now. Rudo's asking if this is for an hour and 30 minutes. Nope, it's for 30 minutes. So roughly. And it'll be like another 20 minutes or so. Oh, why does Mars have Marsquakes? Thanks for reminding me, Lily. I forgot to answer this question. Right, yeah, the reason why Mars has Marsquakes, which no one seems to remember when I explained it before, or maybe none of you are on from the live I did last time. Because of course, this is a repeat, this one. So some of you might have already seen what are the tipping points for our climate. Right, so Earth has earthquakes because you've got the tectonic plates all over the world that are like sliding past one another and pushing into one another, and that's what creates Mount Everest and the Himalayas, is those two plates pushing into one another. And that's all because of like the volcanic activity and the molten core. But Mars doesn't have a molten core, which is a big problem for Mars, and that's why it's got no atmosphere. And I talk about that in another live. But why does Mars have Marsquakes? It's because it has no atmosphere, and so it bakes with the heat of the day and then gets super cold at night. And so the surface is constantly expanding and then contracting and expanding and contracting. And so you get these earthquakes that happen on Mars. They're actually really small compared to Earth. Anyway, Frostbite is also saying hello. So right, let's do it. I think it's time to start. What are the tipping points for our climate? So thanks everyone for coming. We shall begin. So first of all, tipping. Right, there are loads of different tipping points for the climate, and we don't know which ones are the ones we have to worry about most because we don't know when the tipping points will come. So what you need to imagine, if you don't know what a tipping point is imagine that this here, let's just draw it in here. This is like a cliff face. And there is a big piece of metal that's kind of balanced on the edge of the cliff face. And if you are walking out along it like this, and you walk further and further until you get out to here, then imagine that as being pumping more and more greenhouse gases into the atmosphere. Eventually, we're going to get to a point when there are going to be so many greenhouse gases in the atmosphere that things are going to get out of control, but we don't know when it is. It's like, if we just keep moving a tiny bit further, then eventually it might all fall apart. In fact, Lily's saying that she saw the video that I did with a bit of paper. Lily's also saying, would that make it hard to live on Mars? Oh god, yeah. Living on Mars would be absolutely terrible. It would be so much worse than living in the Antarctic. Like, go, if you want to live on Mars, try the Antarctic first, then you'll come home and be like, whoa, I do not want to go to Mars. Because Mars is like the Antarctic, but much colder and with no atmosphere, and so no living things, and also any message you exchange with Earth, you can't have a telephone call with Earth because it takes such a long time to get the information between Earth and Mars. That just be a huge delay as well. I'll be an absolute nightmare. Anyway, right, yes, so this is a demonstration that Lily's already seen, but I shall show you guys because this is a really cool way to explain what we mean by tipping point. So, here we go. In fact, wait, let me go full screen to show you. Okay, so imagine that this piece of paper is the climate of our Earth. Now, as we pump more and more greenhouse gases into it, it becomes more and more unstable. But for a long time, it's fine, and we don't notice any problem. But eventually we get to a point where we've pumped so much greenhouse gases in that we have some kind of collapse and things start to get out of control, and in a way that it's very difficult for us to turn back the clock. What I mean by that is this. Some people might think that in order to go back to normal, we just need to pull a little bit of greenhouse gases out of the atmosphere. But look what happens as I move my fingers up the paper. We're still in that collapse point. and I can keep moving my fingers further up the paper, and we're still collapsed. We actually need to go so far back in the other direction to bring things back to how they are now, that is one of the biggest reasons why we have to act so urgently on climate now, rather than waiting and being like, oh no, it'll be fine and we'll start dealing with it when the problems actually come. By the time the problems come, we're already far too late. And this is why it's so important to think about the tipping points and how we can avoid them, because we absolutely have to avoid them. Okay, so okay, right. So let's do it. What are the tipping points for climate? Abigail's just come in late and missed the explanation for the seeds. It wasn't the fires. It was a disease called Rinderpest. Rinderpest swept across the savannah and killed a lot of the grazing animals. And so basically, acacia trees had 1 year or a year or so to gain their to lock themselves in. Right. So let's move on to some tipping points. Right, here are some more trees because I like trees. But actually, before we talk about trees, I want to talk about one of the most powerful greenhouse gases. Can anyone name some greenhouse gases that are greenhouse gas? Can anyone name some greenhouse gases that are more potent, so more powerful than CO2? Now, for those who don't know, a greenhouse gas is a gas that encircles the Earth, and when the heat of the sun comes in, this gas stops the heat of the sun from leaving so easily. Now, we actually need greenhouse gases. If there were no greenhouse gases at all, the world would be a ball of ice. It would be freezing cold all over the planet. But the thing is, we have a certain amount of greenhouse gases that's a nice balance for the life that exists right now. And it's fine for greenhouse gases to change. Sometimes in the past, greenhouse gases are really high. Sometimes they're really low compared to what they are now. And that's fine because they've got to those points quite slowly. And so all the life on Earth had hundreds of thousands, if not millions of years to adapt to all these changes. However, what's going on now is that the level of greenhouse gases are going up so quickly that a huge amount of life on Earth just will not be able to cope, and so we're going to have huge nature collapse, which will result in, we completely depend on nature ourselves for our lives. Just everything from our food to our medicines to the air that we breathe. And so collapse of these natural systems is a total disaster if it happens. And that's why scientists are so scared of the tipping points for our climate coming up, and that's why it's so crazy that a load of politicians just don't seem to care. But you can see what's happened with the pandemic at the moment, where loads of scientists were basically like, it's going to be really bad, this, and governments just didn't act very quickly. And this is something that we need to look at and learn really seriously about climate, because we need to act really, really fast. Otherwise, we're going to be in trouble. Right, okay, so greenhouse gases. Let's talk about some greenhouse gases that are more powerful than CO2. So, Leonard asked what Rinderpest is. Rinderpest is a disease that swept across a lot of the cattle, or like bison or those kind of creatures. Anyway, I need to move on from Rinderpest. But you can watch all these back on the website. They all get posted up on the website, which is here, aimhigh.co. Right. So GHGs that are more powerful than methane. More powerful than CO2. So I'll just put CO2 in there as well. But yeah, methane is a really good one. So methane is a very worrying greenhouse gas that I will get back to in a moment. And Rudo is saying SF6, which is a good one as well. Yeah, that is spelled right. Sulfur hexafluoride. And Marion is saying N2O. So there are lots of like nitrous oxide type gases that are greenhouse gases. But the one I was looking for was, and Frostbite said laughing gas, which is another NOx one. But the one I'm looking for was water vapor. Yes. Okay, H2O. So H2O is actually a really, really powerful greenhouse gas. Now, it's not one we normally worry about because the world has a natural system to kind of H2O goes into the air and then H2O comes back out of the air as rain and so on. However, you can count it as part of a kind of tipping point because it's a very powerful greenhouse gas, right? And as the world heats up, you'll have more water that's evaporated in the air. And because you've got more water that's evaporated and it's inside the air above us, so if that's the top of the atmosphere and this is the planet, then the more the world heats up, the more you're going to get more water evaporating and sat inside this layer. And so that will act as a stronger greenhouse gas, trap even more heat, which will evaporate even more water, which will make this layer even more full of water, which will heat up the world even more, and so on. So that's the way that things can start to get out of hand, and that's why we call it one of the tipping points for our climate. Lily's talking about droughts. There will be droughts in some areas, so certain areas of the world will get drier. Certain areas of the world will also get wetter. Actually, we currently think that the water distribution will change such that there'll be more rain over the oceans and less rain over the land mass on average, which is obviously a really bad thing for us because we need it to rain on land. And that's, again, if we allow these things to keep going, and that's why we have to turn this around. Right, trees. Why are trees such an important tipping point? What do you guys think? Trees? Why are trees such an important tipping point to consider for our climate? Now, I know this is a little bit to write, so I'll just give you guys... Marin's just posted an article about lots of H2O getting into the atmosphere. So yeah, why are trees an important tipping point? I'll give you guys a moment to write this and just one more time welcome anyone who's really late, since I just saw someone else say hi. Yeah, if you're running really late for this, then Mr. Name High Live. So ask questions whatever you want. We're talking about what are the tipping points for our climate, and yeah, you're welcome to get involved. If you're watching on one of my channels, then head here afterwards because this is where all the action is with all the other people who are doing these. Okay, so Sarah's saying the trees give us oxygen, and Rudo's also saying they're a source of oxygen. And Marin's saying, no, of course I don't mind. I hope, in fact, Marin, I hope it's reposted to the other places. Not because the problem is, if you're on Facebook, you can't see everyone else's comments, whereas on all the other platforms, you can see what everyone else is chatting about. So on Facebook, it must seem a bit quiet. Anyway, so, right, trees are an important tipping point because if the world gets hotter, a lot of trees that are used to living in quite wet environments will end up in very dry environments, and you will get what we had in Australia and still have to a certain extent, huge fires that will wipe out the forests. Now, fires produce CO2, and also they destroy the trees which were previously absorbing CO2, so that process stops. So if the world gets hotter, trees get destroyed, and trees being destroyed is very bad because it both releases CO2 and prevents CO2 from being absorbed. So again, that's another tipping point because the further it goes, the worse it gets. Right, next thing. So, in fact, I'm going to skip over that one and I'm going to go straight to here. I'm going to go straight to here now. This is, does anyone know what's going on here? Yeah, what is this? What is in this picture here? Sorry, it's meant to be a question mark. I've just got it completely wrong. I've just forgotten how to do question marks. There we go. Exactly, yeah, so Leonard's saying coral, Frostbite's saying coral, and Sarah's saying coral as well. So this is coral dying. So this is healthy coral, and then this is what coral looks like when it's been bleached. Now, if you want to know why that happens, why bleaching of coral happens, then just check out. It's one of the latest videos that I posted on my Instagram and my YouTube. So just check it out on there. That's my name. Yeah, and that explains why the coral is dying. But still, one of the main things that I want to talk to you about, because this is a big tipping point, is the ocean getting more acidic. So about one... Oh, actually, I'm not going to tell you. I'm going to ask you. What do you guys think is the what do you guys think is the proportion of all the CO2, the extra CO2 that we've produced since the Industrial Revolution that we think has gone into the ocean? So how much of the CO2 that we've produced has been absorbed by the ocean? What do you reckon? So Lily's guessing a sixth. It's just a guess, but a fine guess at that. Frostbite's guessing a half. Yeah, okay, right. I'm just going to take roughly, not quite the middle, but roughly the middle of what you guys said. It's about a third. So yeah, we think the ocean has absorbed about a third of the CO2 that we've produced, but again, this is not not a hugely accurate figure, and it could be something quite different. But it's kind of a scary thought in some ways that the ocean has absorbed loads of what we've produced for it, and stored it and kind of allowed us to ignore it for longer because it's taken it out of the atmosphere. But the ocean can't carry on absorbing carbon dioxide always, and also this causes a very big problem. So when carbon dioxide dissolves in water, it forms an acid. And the acid is one of the things that is highly destructive. The acid is one of the things that is highly destructive for coral. So the coral is having to cope both with a more acidic ocean and a hotter ocean. And coral is really, really sensitive. It's really sensitive to changes. And so that's why it's dying off very rapidly. But coral supports about like an unbelievable 50% of all of the life, all of the species in the ocean are thought to be supported by coral. And the coral is dying off incredibly rapidly. Now, why is it such a problem that loads of species in the ocean die if they're just in the ocean over there? Why is that a problem for us? Why does it matter that 50% of ocean species might die off if loads of the coral reefs collapse? And while I'm waiting for answers to come in about that, I'm going to tell you something quite cool. This is an interesting aside. So did you know that as the oceans get more acidic, they're actually also getting noisier? They're getting louder, which is really weird. But it's because there's a chemical in the oceans called borate, which you can remember because it sounds like boring. And borate is kind of like cotton wool for the ocean in that a sound hits a borate, the borate absorbs the sound and then turns into something else and then turns itself back into borate so that it can keep doing it. And borate just absorbs all the sound, so it muffles the ocean. So it's kind of like a whale wearing like earmuffs or something, but in a chemical form and all through the ocean. So there we go. So yeah, borate is this muffling chemical in the ocean that makes the oceans quieter. And as the oceans get more acidic, that destroys the borate, and so the oceans get louder. And this is another big reason why lots of animals in the ocean are struggling to adapt, because suddenly the sounds that used to just be local to their area are just like, the ocean's just very, very noisy. This probably feels like it's becoming very crowded and deafening, but actually it's becoming less crowded because loads of the species in the ocean are dying. So, Mango Jelly's just joined the chat. Welcome, Mango Jelly. You're a bit late because we're kind of getting to the end of this. But this is about what are the tipping points for our climate. And I was just explaining why the oceans are getting noisier because we're running out of borate, which is the thing that absorbs all the sound and that's being destroyed by the acid. Okay, so why is the coral so important? Let's see what people say. So Catherine's saying to do with the food chain. And Lily's asking if coral is an animal or a plant, and does it have a brain? Lily, it's an animal, and watch the video I made. It's on my YouTube. My YouTube is called for those who haven't seen it before. My YouTube is called Science in the Bath. Science in the Bath. But one of the most recent videos I made explains all this stuff about coral. And I would explain it to you now, but I'm just aware that we're running out of time and I want to show you some other things. But check out Science in the Bath if you want to find out why the coral is dying, because that explains it. Okay, so Lily again is talking about the food chain. And so Marian's talking about doing an MSc. And Marion, when she was studying, her friend, so just recounting this story to other people. So Marion is talking about a friend who was studying some corals, and after a huge bleaching event in the ocean because of high temperatures and acidity, that friend realized that the coral they had in this tank was the last remaining of that coral, potentially anywhere in the world. And yeah, again, Sarah's saying home for fish. So the reason why we need our coral to be healthy, and this is so important, is because one of the things that people really underestimate when they're talking about CO2 in the world is and greenhouse gases is people think the solution is, well, we need to just pull the greenhouse gases out of the atmosphere. And people think, and obviously the other solution is we need to stop producing them, so we need to stop using fossil fuels, and that's very important. But the one thing that people always seem to or the one thing that hasn't been well linked, I think, for a lot of people is this: it's all about nature. Nature is by far the best carbon sink for in the world. Healthy natural systems will absorb all of these greenhouse gases that we're so worried about from the atmosphere and just put them into biological systems. If you have healthy coral, then that supports 50% of the species in the ocean. 50%. If you have healthy coral, then there's far more life in the oceans than there is on land. If you have healthy coral, then that's a huge win for absorbing greenhouse gases out of the atmosphere. The problem at the moment is that we're simultaneously filling the atmosphere with loads of these destructive gases, and we're also destroying loads of the life that could be absorbing it all for us. This is why we have to protect forests, and this is why we have to create much more wild natural space, because at the moment so much of our space is just is taken up by farms and industry and so many pollutants and things are pumped into the ocean, and the ocean is completely disrespected. And the ocean is like, we are completely dependent on the ocean. The ocean, to be honest, would probably be fine without humans, but we would not be fine without it. And so, yeah, the coral is yet another tipping point that people watch in fear as it just vanishes all around the world. As you can see, it's all turning into this ghost town, which has no fish and no life being supported, and it's a total disaster in many ways. Anyway, right, so there are lots of other things I could talk about, and in fact I will just very quickly talk about methane, because I know that I promised I would. Does anyone know, well, I've said what it is now. This is methane leaking out of ice in Alaska. Now, this is another classic tipping point, because the ice in this area is full of methane. It's full of methane that's stored underground. So you've got lots of methane stored in this ice underground. And as the ice melts, because the world's getting hotter, it releases methane, which if you put a match to it, you can actually set on fire as it's coming out. And it releases methane, which is a far more potent greenhouse gas than CO2. How much stronger do you guys think methane is than CO2 if you measure over 100 years? What do you guys reckon? Over 100 years, how much stronger is methane than CO2? Bring your guesses in. But yeah, as the ice melts, it releases methane. And as it releases methane, that goes into the atmosphere, which makes the world hotter, which melts more ice, which releases more methane, and so on. Another tipping point that we are terrified of getting out of control. Okay, so Lily thinks 20, Miz thinks 10, Ross thinks 20, Jeffrey thinks 50, Leonard thinks 60, and Leonard wins this one because it's 83 times more potent. Mike Jelly came in with 90, which is actually the closest. Yeah, it's 83 times more potent than CO2. So methane is incredibly worrying, and obviously there are quite small amounts of it at the moment, but there's vast stores of methane stored under the northern and southern ice. We call it the permafrost. Perma because it's supposed to permanently befrost. Every single year, it's supposed to never melt, and yet it is now starting to melt because the world is heating up so much that even the whiskers of this seal are starting to melt. Right, okay, I'm just gonna very quickly end on this comet. This has nothing to do with tipping points, but I just think this comet is really cool. So yeah, you rarely see comets in the sky because they don't spend much time close to the sun, because if you've got the sun here, then a comet's orbit is kind of like that, and it does this whole bit like super fast, and this is the bit when it's near to Earth, and it does this whole bit like crazy slowly. It can take like many decades to do the bit really far away from the sun, and so you don't see comets very often. But here's a comet called Comet West, which was so bright in the sky that just with a completely normal camera you could take a photograph like this. They said that it was like the brightness of 1,000 suns. Anyway, I wish I'd been around to see Comet West, but I think it was quite a long time ago, like many decades ago. But maybe we'll get a cool comet again, and that'll be really good and nice. Right, okay, so I'm going to answer some questions in a mo that I see popping up in the chat. But before I do, I just want to say thanks everyone for coming. This has been an Aim High Live. So yeah, check out here if you want to see more of these from other people. I am going to be back in literally 25 minutes to do another one, which is going to be on like electricity, like the electricity that school makes really hard, and I'm going to make it really simple, basically. So any of your friends who've been struggling with electricity stuff, let them know that I'm going to do that in 25 minutes. And so that's going to be more like syllabus-based stuff. I'll throw interesting things in as well, but I'll basically just explain like how to do electricity. So yeah, I'm going to do that in 25 minutes, and that's going to be up to like GCSE, so up to like age 16 electricity. But if you want to catch up because you missed it and you're older than that, then come for it as well. But it'll also be understandable for anyone who's like 11 plus, basically. And then in the afternoon, I am going to do my other one. Oh, yeah. Okay, so a total like departure from what I'm supposed to be doing. The afternoon, so this is 1 o'clock my time, which is in what, like 2.5 hours or something. I'm going to do one on politics. So I'm going to explain who really runs this country and how it actually works, because when I found out, it blew my mind, and I want to explain it to people because I think it's quite interesting. So yeah, that's going to happen later on. So do tune in here, and then also there are, oh my God, there are so many other things coming up. There's one coming up at the equivalent of like 6 p.m. tonight, which is Do Borders Really Exist, which Hannah is running, and Hannah's bloody great. And then, tomorrow is Love Poetry and How White Will Ruin Your Life, and that's from Phil. And then I'm doing one on how to commit fraud and get away with it. How to commit fraud and get away with it. So anyway, there's loads of cool ones coming up, and I'm looking forward to seeing you guys later for more of those. Do tell your friends and do spread the word, because yeah, it's more fun basically. The more people that are in the chat, and it makes it a lot more worthwhile for us basically doing this, because yeah, we're keen to help as many people as we can. So thanks again for coming, and I will just very quickly answer a couple of questions that came in for those who are interested. So Mango's asking, why does the seal have ice on it? It's because it's icy times. Wait, let's go back to the thing. And then there was Lily's asking, where does methane come from other than the ice? So there are lots of different sources of methane. One of the big ones that we worry about is cows and sheep. So these animals basically, like, for all the way through history, we were like, cows and sheep, brilliant. They take grass, which we can do nothing with, and they turn it into food. But actually what we didn't realise is that they do that really inefficiently, and they produce tons of methane as they're doing so. And so now we've realised that cows and sheep are one of the biggest producers of greenhouse gases on the planet. And we're now in a situation where if you take all of the land mammals and you put them in a pile, so all of the mammals on land, like the elephants, the tigers, the squirrels, like all of them, over 50% of that pile is cows and sheep. Over 50%, like way more than humans. And they're all producing loads of methane. So that's a big worry. And Jace is asking, what about the zooplankton that are encased in the ice caps that are huge CO2 eaters? Jace, I have not heard much about that. I'm a little bit skeptical about that. I think there might be some zooplankton that can absorb CO2 that are trapped in the ice, but I don't think it's significant enough. But I'm going to look into that. But also thanks for raising it, because I love hearing about things like that. And yeah, the reason, Jace, the main reason why I'm skeptical is because I work with loads of like climate scientist people, and if there was some like magic bullet hidden in the ice that was going to save us all, then they'd be totally chill, and they're not. They're all really worried. Okay, so and Frostbite is saying that, did you know that insects are attracted to light? I know it's nothing to do with the topic, but I wanted to ask. Yeah, mate, insects love light, and it's not. Sometimes it's not quite that they're attracted to the light; it's that they like moving parallel to it, which is why you'll see like moths will move like around and around a flame, because they're trying to keep the moon on one. It's like normally they try and keep the moon on one side of them, because then they know they're going in a straight line. But for a candle, they just end up going round and around the candle, and it's crazy. Right, and Catherine's asking, what's my pencil? Oh, right, this is just what I use to draw on the board. um, anyway, right, I'm going to go now. So, thanks so much for coming, everyone, and I will see you in 20 minutes if you're coming back for electricity, or later on if you're coming back for politics, or tomorrow if you're coming back for how to commit fraud and get away with it. Right, farewell, everyone. Bye.